Before digging into more detail on packet switching, let's do a brief review of what we just learned. In circuit switching, we reserve the resources along the path from source to destination for the duration of the connection. This is done by allocating the resources either by time or by frequency. In packet switching, we do not reserve resources. We use store and forward, and at each link, we send a packet at full link capacity when the link is available. The end-to-end path from the source to the destination is calculated using routing algorithms. Outgoing link decision for the packet on each switch, which is called forwarding, is based on forwarding table that is populated during running of routing algorithms. Remember we said that packet switching allows more users to use the network? We want to see why and how. Through an example. Imagine we have n users, each connected to the first router using a 1 megabits per second link. They're all connected through this router to the rest of the network using a 1 megabit per second link. Assume each user sends 100 kilobits per second of data when active, and each user is active only 10% of the time. If we use circuit switching, we can only have 10 users using this network at the same time, meaning n equals 10. This is because we have to reserve 100 kilobits per second out of the 1 megabits per second link for each of the users. We will not have any capacity for any more than 10 users. Even knowing that each user is active only 10% of the time, we cannot release the resources during 90% of the time that the user is not active. Therefore, we can only support 10 users if we use circuit switching. Now consider packet switching. We know that each user is active 10% of the time. So, the probability a user is active at any given time is 0.1. And the probability that a user is inactive at any given time is 0.9. Let's play with a random number 35, saying n equals 35. With 35 users, the probability that at any given time, exactly 10 users are transmitting simultaneously, and therefore using the link at full capacity, could be found by calculating the probability of all possible permutations of exactly 10 active users and 25 inactive users. This probability is very small. What about more than 10 active users? Remember that we could not support this in circuit switching. With packet switching, however, the probability is found by summation of similarly calculated probabilities for 11, 12, 13 users and more. This probability is very small. Therefore, we can say that 35 users could be supported in this network using packet switching. With a simple example, you can see how with the same network, packet switching can enable higher number of users to use the same resources for communication.